Once again, welcome to the second lecture on stereoisomerism for class 11, 12, 13, 14 and onwards for any kind of competitive tests, including NEET, JEE Advanced and other tests. And those who will be pursuing chemistry in their career, that will help a lot, because the three-dimensional aspect of a molecule and its consequence that is studied in this part of chemistry. So yesterday we discussed the general difference between configuration and conformation, which are the two hands of stereoisomerism. One hand is configurational changes, the other hand is conformational changes. Who can tell me? Samidha, can you tell me the difference between the configuration and conformation of a molecule?
The configurational means bond is broken and is remade, but in conformational only rotation occurs and no breaking or remaking.
So you mean to say, welcome those who are watching from the YouTube directly. Welcome to our fascinating sittings on stereoisomerism. Yesterday, those who have already watched the video, if not watched, then please do so. That will help you in understanding better today's sitting. Yes, Samita has rightly told that a structure can have more than one stereoisomer. That stereoisomer may be configurational isomers or maybe conformational isomers. So if you want a configurational isomerism, it has to have certain requirements. It has to have a steric center, a stereogenic center or stereo center. Without a stereo center, one or more stereo centers, it's not possible to have a configurational isomerism. But yes, for conformational changes, you do not need any stereo center. You need only single bonds. Single bonds. The rotation about single bonds is highly allowed because the barrier to rotation is very, very small. And at room temperature, a cyclic compound, the CC bonds, they rapidly rotate. Maybe in 1 second, 10 to the power 10 times or more, it rotates so rapidly. And at a given point of time, you will find a particular conformation or conformer will be abundant, which is more stable. So what Samidha told, that for changing conformation, you do not need anything, only to dance, to rotate the molecule across a single bond and see if you are getting some more stable arrangement. That is a conformer or conformational isomer, which we shall study in acyclic compounds, in ethane, butane, and so on. And also in cyclic compounds, we'll take the cyclohexane as one example to study about the conformational changes in cyclic compounds. And in configuration, we have two aspects. One is geometrical isomerism or EZ isomerism, which need a double bond, C double bond C or C double bond N. Shall talk about C double bond N later. sp2 carbon, at least two. One double bond means, by default you need two stereo centers. And each carbon should be bonded to two different groups. In that case, it's a planar system. At that particular part of the molecule, it's planar. And we have two different arrangements, whether the groups, identical groups or higher priority groups are lying on the same side or opposite side. Accordingly, they are called E and Z. We shall be learning in details. We have not studied anything in details about the EZ isomerism. Just I have introduced. But Rudra, can you tell me that these EZ isomers, they are stereoisomers, no doubt. They are configurational isomers. As Samita has rightly pointed out, that bond breaking and remaking has to be done at a particular stereo center, a particular atom, not at different atoms. If you break a particular group or atom from one carbon or one atom and you fix it in another atom, then you are getting a isomer, a structural isomer. You are changing the structure, the name. But if you make a switch or swap between two groups at the same carbon, and if you generate a new form which is non-superimposable with the old form, then the two are stereoisomers. And in the case of geometrical isomers, they are not mirror images. They are never ever mirror images. They are never mirror images, but they are not superimposable. So what is the other name of these stereoisomers which are not mirror images, which have no optical response? Master Rudra.
Diastereoisomers.
Yes, precisely, diastereoisomers or simply diastereomers. Sami, you also thought in the same way?
Yes, sir.
Very good. And we shall see today in optical isomerism also will be coming across diastereomers, which by convention we call it as optical isomer, but it should not be called an optical isomer, it should be a diastereomer because it is optically inactive. We will find in case where you find a mesoform which is optically inactive, that is not, we count, but that is strictly not an optical isomer. It is a diastereoisomer. Diastereoisomer is a big term. It the two stereoisomers and more so configurational isomers which are not mirror images. Diastereomers, that term is not applicable for conformational isomers. Any question? Any question, please?
No, sir.
No, sir.
And for optical response, now a question open to anyone, to you who are in Zoom, and also those who have already started watching remotely in the YouTube. Question is, what is the structural requirement for a molecule to be optically responsive, responds to PPL, either to the right rotation or to the left rotation? It interacts with the PPL and responds, interacts with it. What is the prerequisite qualification of a molecule? Yes, anyone? Raise your hands. Yes, Rudra?
Presence of chiral centers and presence of chiral axis.
Oh, well, you have elaborated the answer. You are correct. But you have to give me the most condensed answer, brief, in one word or maybe two words. Yes, Samita, can you try?
Dissymmetry.
Yes, molecular dissymmetry. Molecular dissymmetry is the cause of chirality. So let me start today's. Let me share my screen and start today's proceedings. So we will be focusing on optical isomerism now. Which is a part of configurational isomerism. Molecular dissymmetry is the only cause of optical activity. And optical isomerism. Now my second question to any one of you, what are the factors responsible for a molecule to become dissymmetric? So that, and if it is dissymmetric, then the mirror images are non-superimposable. And one rotates EPL to right. Already you have written called D, and the other to the left called L or minus. Now my question to you is, what are the factors responsible to make a molecule dissymmetric? Yes? Anyone? Sami, you are equally intelligent, but you must be smart. You should. Yes, I would like to hear the answer from Sami.
The presence of chiral center and chiral axis.
Well, see, that comes secondary. Those are not primary. But primary, I want to hear from you. Rudra, I have already told. There are two aspects of optical activity. One is the presence of chiral center, one or more chiral centers, chiral atoms. And the other one is the presence of chiral axis. Okay. But those are not the factors. Yes. Now tell me, what are the factors responsible to make a molecule dissymmetric? Rudra, this is pathetic. We have written together you have also written, I can give you a hint, absence of. Absence, yes.
Sir, absence of plane of symmetry, center of symmetry, and alternating axis of symmetry.
Precisely. Precisely. This is the main thing. The molecule should not have any one of these three elements of symmetry. Today, I will discuss with you the details about the elements of symmetry. He might be thinking it's not required. Why are you poking your nose in such weird things? Not you, but some of you might think. But let me tell you that those will be required. That knowledge of symmetry is required for any branch of science or engineering that you pursue. Knowledge of symmetry will be useful everywhere. If time permits, then I will also like to teach you the symmetry properties and group theory. Group theory is a mathematical tool to apply in biological systems, in chemical systems, in physical systems, and to predict many important conclusions. So those are taught in higher classes, but I can present to you in a very simple manner, but not today. Don't be scared. I'm not scaring you. So the factors for molecular dissymmetry, I have to write again. E R or R, absence of what? Sigma. What is sigma? Miss Samida.
The plane of symmetry.
Yes, plane of symmetry. Here, let me introduce. How do you define plane of symmetry? Have I written that? It is an imaginary plane passing through the middle of the molecule, which divides the molecule into two halves, which are mirror images of each other. They're not identical, they're mirror images of each other. I am just giving you an example of water, which is a V-shaped molecule. There is a plane which will pass perpendicular to the plane of the paper or my screen. So that plane passing through the middle, I am unable to control. This plane, which is perpendicular to the plane of the paper or of the screen, so that is a PS, because this hydrogen will be imaging with this hydrogen will be imaging with this hydrogen. They're equidistant. Object distance is equal to image distance. So therefore water has H2O molecule has a plane of symmetry. So every molecule can be thought whether it is symmetrical or not. More the molecule is symmetrical, you will find more number of symmetry elements. And there are 4 symmetry elements. 3 we have already discussed. The 4th one also I have sounded you, but I will be telling in details. Now, at this structure to be better if I tell you so this is supposing a water molecule. My fingers are holding oxygen atom. My fingers, the thumb and the forefinger, they are holding the oxygen atom. And these are the two hydrogen. And this plane carrying the atoms is like this. And another perpendicular plane which passes at the midpoint, that imaginary plane will divide this molecule into two halves which are mirror images of each other. So then we say this imaginary plane is a plane of symmetry. You understood?
Yes, sir.
So if a molecule has a plane of symmetry, then it is symmetrical and it is achiral. And the second one I will introduce, the absence of one is sigma, two is I. What is I?
Sir, inversion center.
Oh yeah, many people call it inversion center. Let me define it. Once for all, let me define it. It is an imaginary point mirror. Imaginary point mirror at the midpoint of the molecule. A point mirror is a point mirror at the midpoint, at the center of the molecule. And the image of all atoms and bonds through that point mirror exactly superimposes the original form before reflection. Or in other words, to put it more simply, if we draw imaginary lines, straight lines through the center of symmetry, through the inversion center, through I, then it will touch identical groups or atoms at equal distances. It will touch identical groups at equal distances. Hello and welcome those who are watching in the YouTube. You will definitely, if you are really an aspirant, you will definitely enjoy the sessions that we'll be having for stereoisomerism. That means, supposing I will draw a molecule like this, where is a chlorine atom here, hydrogen here, chlorine here, hydrogen here, say COH here, H here, COH here, H here, and another molecule, but I will have a different configuration, chlorine, hydrogen here, chlorine, hydrogen here. This is a square, it's a cyclobutane derivative. So here, this is COHH, and this is COHH. Now tell me, in the first molecule, what is there, and in the second molecule, what is there. Both are achiral. Both are achiral. Are you not able to find a plane of symmetry in first?
Sir, in the first one we have a plane of symmetry, and in the second one
Yes.
we have center of
How?
symmetry.
Because dekho, if you consider carbon number 1 and carbon number 4, and you pass an imaginary plane, then you will reflect this one with this one, hydrogen with hydrogen, and chlorine atoms are sitting on the same plane. They are sitting on the same plane. So this is a sigma, it has a sigma. And also this molecule, supposing I would change it to this molecule, ClH, ClH, COOH, H, COHH. This also has a plane of symmetry, this will be passing in the middle, perpendicular to the plane of that cyclobutane ring, and this chlorine images with this chlorine, this OH images. So this has a PS, this has also a PS, but it's difficult to find. You can also imagine another PS. So there are two PSs. The more number of symmetry elements, because in group theory, we will count the total number of symmetry elements. PS, how many PS? And axis of symmetry, how many? There are so many types of axis of symmetry: C2 axis, C3 axis, C4 axis. I will explain. So accordingly, the molecules, inorganic as well as organic, they constitute or they belong to a certain point group which have similar or identical elements of symmetry. So that you have another, I'm unable to draw three-dimensionally. You can have another passing through this and this. So, but not at the midpoint like this. But here, what you have? This molecule.
The chiral center.
Chiral, why you are meaning they are achiral molecules? Are you, since it is a public video, I cannot, I cannot put any funny words.
The center of symmetry.
Yeah, center of symmetry, because this particular center is a center of inversion. Because if you draw imaginary lines, you will find identical groups will be touching the line at equal distances. In other words, if you reflect the entire molecule through that point mirror, then the image will be superimposable with the object. That means they are diagonally, they will be reflecting. Sami, am I clear to you?
Can you explain center of symmetry once again?
Now, although I'm taking a planar molecule which is not optically active, whether the groups are same or different, whatever, they are not optically active. But I'm showing you the simplest example to distinguish between a plane of symmetry and a center of symmetry. Now, you see this trans. This is a trans butene. The red ones are, say, methyl, and the white ones are hydrogen, and these two I am holding, they are carbon atoms. And the entire red is methyl. You presume that the entire red ball is methyl. Carbon with 3 hydrogen, they have been condensed to a red ball, and this is a red ball. Now, this molecule, tell me, has a plane of symmetry or a center of symmetry, a center of inversion.
Symmetry.
Hmm?
The center of symmetry.
Why? The center is at the mid, exactly at the center of the molecule. Not that all molecules have a center of symmetry, because the two atoms are, two groups are methyl, methyl, two groups are hydrogen, hydrogen. Then only, and they are positioned in such a manner that if you draw lines through that imaginary center, as many number of lines you draw, you will find identical groups will be touching that line at equal distances. That means that about the center, you will find the identical groups will be at the diagonal positions. Now, am I clear?
Yes, sir.
But if I make a cis one, for example, I will make a switch and convert the trans into cis. Then does it have a center of symmetry?
No,
No.
sir.
Center of fact.
Center of symmetry, you have to draw lines, straight lines, as many number of straight lines. Some straight lines will touch you, your nose, empty space. They will not be counted. But those lines will touch groups or atoms. They will be touching identical groups at equal distances. That means the atoms or groups, they will have images diagonally. Understand? But what element of symmetry this has?
Plane of symmetry.
Plane of symmetry.
Yes, if you consider an imaginary plane perpendicular to this plane of the molecule passing at the middle, that plane will reflect one half as the mirror image of the other half. If one half is the object, the other half is the image. If the other half is the object, the other, the previous half will be the image. They are mirror images of each other. So this has a plane of symmetry, but not center of symmetry, but the trans has a center of symmetry. You understand?
Yes, sir.
So, but funnily, I would like to invite an interesting answer to my second question. Who can prove that this molecule has also a plane of symmetry? Therefore, I told you from the very beginning that no Plaban molecule, however, dissymmetrically substituted it may be, they are chiral. They are chiral. They have a plane of symmetry. Where is the plane of symmetry? Whether it is cis or trans, they have a plane of symmetry.
Sir, there is a plane of symmetry in which the molecule itself is lying the four
Yes.
molecules.
Yes. Planar molecule ରହିଛି molecular axis bato dekiri, the centers of each atom and the molecular axis bato dekiri जो plane ଯାଉଛି, that plane carrying the atoms फाळे ରହିଲା ଉପରେ, ଏଇ ନାଲି ସ୍ପିଅର ର ଫାଳେ ଉପରେ ଫାଳେ ତଳେ, ଧଳା ସ୍ପିଅର ର ଫାଳେ ଉପରେ ଫାଳେ ତଳେ, ଏଇ ଧଳା ସ୍ପିଅର ର ଫାଳେ ଉପରେ ଫାଳେ ତଳେ, and so also this. So in this case, I'm sorry if some of you are not able to understand Odia, then I am explaining in English that the molecular plane, that is called the molecular plane, that itself is a plane of symmetry. That is present in all planar molecules. I am not considering that. But center of symmetry is only present in trans, and another plane of symmetry besides the common molecular plane of symmetry, another vertical plane of symmetry is present only in cis. Got it?
Yes, sir.
Similarly, if you have a square, supposing you imagine a square, I am addressing to Sami and others who would not understand. Supposing we have a square cyclobutane, which is almost a square planar, but all the 4 carbon atoms have substitutions. So one, supposing here is 1, carboxylic acid is up and hydrogen is down, and in the opposite diagonal position, carboxylic acid is down and hydrogen is up. And in the second position, supposing OH or say CH3, CH3 is up and hydrogen is down. And its diagonal position, methyl is down and hydrogen is up. So methyl here is looking to another methyl diagonally. Carboxyl here is looking to another carboxyl diagonally. So they are mirror images across a point mirror. You understand? If you draw lines through that center of symmetry, it will touch one carboxylic acid at the top of one carbon and the other carboxylic acid at the bottom of the diagonal carbon. You understood?
Yes,
Yes,
sir.
sir.
That's what the position here. Chlorine, this chlorine is in the top, above the plane. This chlorine is below the plane. So if you draw a line, in the figure it looks like it is lying in 2 dimensions. No, it is crossing the molecular plane from top to bottom like this, like these. And here also it is crossing from top to bottom across the center of symmetry. So there is a I here in this molecule. So there is no sigma. It is center of symmetry or center of inversion or inversion center is present here. So the presence of these two will make it achiral, optically inactive. I am saying absence. See, I have written absence of sigma and I. And 3, SN. What is SN?
Sir, alternating axis of symmetry
Or
improper axis of rotation.
improper axis of rotation. Now, for that, I have to just leave some space. Maybe 1 page or maybe 1.5 pages. 1 page you leave. Then we talk about first the fourth one should be, n-fold axis of symmetry. This should be taught first. So in the list of symmetry elements, 4 symmetry elements, sigma, I, then comes Cn. It is the third element of symmetry. Conceptually, before understanding Sn, you have to understand Cn. This is called Cn. Let me define what is Cn. Then you can easily understand what is Sn. By rotating the molecule about 360 by n degree about an axis, an imaginary axis passing through the molecule. The new form after the operation, this is called symmetry operation, is superimposable or indistinguishable with the original form. We can also use the term indistinguishable. Indistinguishable with the original form. So that n is called a n-fold axis of symmetry. Cn, C2, C3, C4. What does it mean? Now, let me take the example of water. Now, don't imagine any plane, any point. Water doesn't have, H2O molecule doesn't have a center of symmetry. doesn't have a center of symmetry. Because the atoms are only one side, not the opposite side. So it doesn't have a center of symmetry. It has got a plane of symmetry. And another plane of symmetry is, since it is planar, another plane of symmetry is passing through the molecular plane. So that is understood. If certain molecule is planar, whether it is H2O or it is B-shaped, any SO2, SO3, any planar molecule, the molecular plane is a mirror plane. And but if you consider an axis, which is a line, an axis, and try to rotate, tell me, supposing you take a picture of this now, and you go to toilet, restroom. In the meanwhile, I shall rotate some degree across a vertical axis. Tell me how many degrees I will rotate, minimum degrees I will rotate, so that when you come back from your restroom, then you will find that nothing has happened. Sir has done nothing to the molecule. No chedkhani has been done. It is exactly indistinguishable. Tell me how many degrees I will rotate.
Sir, 180 degree.
Yes. ତମେ ଯେମିତି ଯାଇଛ ମୁଁ କଣ କରିବି ଏଇ axis, about this axis I will rotate 180 degree. ତାହେଲେ ଯଦି 180 degree rotate କଲି, n ଟା କେତେ 360 ରେ କେତେ divide କଲେ, what factor you divide by 360 so that you will get the repetition of the old form.
Sir, 2.
2. So this is called a C2 axis. So water has a C2 axis. You understand?
Yes, sir.
Every 180 degree rotation, you will find the repetition of the old form. 90 degree rotation कल empty ही empty थिला empty ही no. They are indistinguishable. तुम्हें छाड़ी की जाइचो, फोटो नहीं की जाइचो. Exactly इठी. मुझे धरिची मोर फोटो नहीं चो, आर फोटो नहीं चो. You will find the same thing, but in the meanwhile, I have made an operation that is called a symmetry operation, and more precisely, C2 operation I have done. C2 mane 180, C3 mane 120 degree, C4 mane 90 degree, C6 mane kete 60 degree. So now, let me give the same example. And this is a center. This is not a plane. This is a axis. Imaginary axis. I am writing down sheet 2. So 180 degree. 360 by 2 is 180 degree. 180 degree rotation across or about what is correct? The axis. That name is called C2 axis. Repeats the old form. 90 degree habani, 60 degree habani, 180 degree घुरेबाक पड़ियो. So a molecule रो गोटे C2 axis अच्छी. सेमती मते कुह तमे दरकार पड़ले मु देखैबी. Supposing BF3, which is exactly symmetrical and 120 degree across, the bond angles are 120 degree each. Let me say that a planar molecule. Forget about the plane of symmetry. Say that gote samastangar common. But other plane of symmetry also is there. You find if you pass a plane carrying the central boron and one fluorine, the other two fluorines will be imaging with each other. There will be 3 mirror planes. Are you able to understand what I am saying?
Yes, sir.
Yeah.
So we are not discussing sigma. There are 3 sigmas here. One sigma passing through one fluorine and boron, but the other 2 fluorines will be imaging with each other. And the other one will be passing through the boron and other fluorine, and so also third plane. So we are discussing about axis of rotation, normal n-fold. Tell me what will be the name of the axis?
C3.
Precisely. C3. Every 120-degree rotation about an axis, this axis is vertically going down. This axis is a C3 axis. Because every 120-degree rotation kala belaku tame padeythiba mu rotation kar deythibi dekhalu kichi heini. You understand?
Yes, sir.
So BF3 has a C3 axis. सेमिति मते को जोटा स्क्वायर प्लानर फॉर एग्जांपल गुटे स्क्वायर प्लानर एग्जांपल दियो xenon tetrafluoride. It has got sp3d hybridization with 2 lone pairs sitting at the axial positions and the 4 fluorine atoms. They are the 4 corners of a square. So tell me, such a molecule has what axis?
The C4.
Yes, because these angles are 90 degree. It doesn't look like 90 but 90 degree. So every 90-degree rotation about a vertical axis will produce forms which are indistinguishable. Angle tanka bhitere 90 degree, dana podi 90. So should I show you the model or you have conceptualized?
Sir, conceptualized.
Miss Sami?
Yes, sir, conceptualized.
And then it's time for SN. SN पढ़े आसो एठी कि जोटे जागा छाड़ी च the place which you have left out, come to that. Two successive operations are done. To have a SN axis. First, कौन करिवो? A CN symmetry operation is to be done, and that N will be the SN. Then after that, second operation is reflection, sigma operation. About a perpendicular plane. With respect to the CN. CN is an axis. सेटा अच्छी नहीं सेटा थाउ ना थाउ सेटा न हो तमे आगो CN रोटेशन कर दियो देखो नहीं सुपर इम्पोसिबिलिटी and these two then the new form is indistinguishable with the old form. Dita operation कला परे जो finally आसीबो if that after two successive operation गोटे CN कर दियो but that will not give you indistinguishable form. Then with respect to that axis you take a perpendicular plane that is a mirror plane and reflect one half with the other half. This half will go there, that half will go here. Then you will find if that final form is indistinguishable with the original form, then that axis is not called SN, is not called CN, it is called SN. Now, you must be thinking if this has become little weird. Unless a model is shown to us, we cannot understand what is a okay. This won't be required much, but once you know, why not you understand it? This is so simple thing. Now, supposing this is methane, deliberately I have made these two green, two white, but all are actually white. Only to show you that they are indistinguishable after two successive operations, I am taking this. Now, Supposing these two are to my left, these green are to my left, which are in a vertical plane, and the white are to my right, and they are lying in a horizontal plane. This is a horizontal plane where the carbon atom and the two white ones are lying, and there is one vertical plane which the same carbon atom and the two green ones are lying. Now I will make some rotation. Tell me what CN operation I will do, and then reflect across a perpendicular plane. Then I will have the indistinguishable form. Tell me. Supposing you imagine an axis is passing like this, and supposing I make a 90-degree rotation, right? Now see, 90-degree rotation means which CN?
So C4.
So I make a C4 operation now, so that it comes here, right? So
Yes,
since
sir.
the axis was this, the perpendicular plane is this. So when you reflect the atoms now, these two atoms will have reflection here. These two atoms will have reflection vertical. And these two green ones, which are now vertical lying on the left side, will have their projections, their reflections, their images on the right side horizontal. And these two white ones, which were previously horizontal, now they are vertical, and they will have a vertical reflection on the left side. So the two forms after the successive operations are indistinguishable. Understood or not?
Yes, sir.
Yes, sir.
Now I'm doing it once again. Previously, it was like this. It was like this. The green ones are on the left side, vertical, and the white ones are right side, horizontal. Now, the axis will go from left to right. It is lying on the horizontal plane. It is lying on the horizontal plane. Now, this one. Now, I will make a 90-degree rotation of the molecule about this axis. Now, see, the green ones were vertical, the white ones are horizontal. And if I make a 90-degree rotation, that means C4 operation, then now the green ones are horizontal and white ones are vertical. But that is not the end of our operation. The second operation is a plane, sigma operation, that a perpendicular plane with respect to this axis is this. So when there will be reflection of these two white ones, it will come to the left side vertical, and these green ones will come to the right side horizontal. But remember, all are white. I'm deliberately changing the color to show you what is happening after reflection, after rotation and then reflection. So methane has a S4 axis. This is not called C4. Methane doesn't have a C4 axis. It has a S4 axis. C4 followed by sigma operation. I mean, the sigma with respect to perpendicular sigma operation, will that gives you indistinguishable form, then that is called S4 axis. Now, now we are getting really slow. Doesn't matter. I'm showing you because the CN BF3 has a C3 axis. So also ammonia. Although ammonia is not planar, it is pyramidal, that C3 axis is passing through the nitrogen which is at the apex, and then it is protruding through the molecule and passing through the center of the imaginary equilateral triangle, and the hydrogen atoms are lying at the three corners. So that also has a C3, and xenon tetrafluoride has C4. And I have shown you here the methane has a S4 axis, because first you make a C4 operation. Now successively I have shown you, and then you reflect across. In the picture A, B, C, D, so it will be easier. So AB has now come to the right side due to rotation, but it is now horizontal. CD, which was horizontal, now it is vertical. But when it will be reflected through a sigma plane, that is the same called sigma plane, then that n remains the same sigma plane. Then you get the same original, you get. So A, B, C, D, they are fictitious. They are same. Hydrogen, 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 hydrogen. So these two are exactly superimposable. Don't be, swayed away with the notations A, B, C, D. Eti right side re CD achi, right side re AB achi. But eti right side re dita achi vertical and left side re dita achi horizontal. Eti madhya seya. Kintu C4 operation pore ulti jaichi. Right side re jota vertical tila, seta horizontal hai jaichi. You got it?
Yes, sir.
Yes.
So I think I will copy and paste instead of ଏଠି ଆଉ ଜାଗା ହବ ନାହିଁ, କଣ କରିବା? What to do?
Sir, insert space.
ଏଠି insert space କଲେ ହବନି, ମୁଁ ଜାଣିନି ଏଠି। SN continued ବି ଲେଖି ଦଉଛି। CH4 has a S4 axis. How? We will not discuss more about SN axis, but I clearly explained you the difference between CN. Only rotation, if you regenerate the form, then only CN. And CN followed by sigma, that is called sigma n, will lead you to SN axis. So methane doesn't have a C4 axis, it has a S4 axis. You got it?
Yes, sir.
So the presence of sigma I and SN makes a molecule kon?
Achiral.
Achiral or optically inactive. It will not respond to PPL. However, interestingly, and that is the reason why I told you, because in some year, in multiple years, I have found questions from this. Unless a student understands about symmetry, cannot answer that question. However, the presence of CN, which I have already explained, makes a molecule chiral. I will show you the example. Means optically active. It is dissymmetric. Chiral means dissymmetric. Dissymmetric means optically active. And the mirror image, they are non-superimposable. They are what a D or L. Understood?
Yes, sir.
Yes, sir.
So absence of the following three elements of symmetry makes a molecule dissymmetric and chiral. Dissymmetric means or chiral. Chiral and chiral molecules are, the mirror images are non-superimposable, and they have non-superimposable mirror image forms. ଟିକେ ବେଶୀ ରିପିଟ୍ କରିଦଉଛି କି? ଯଦି ସେଇଟା chiral ହେଲା, dissymmetric ହେଲା, they have non-superimposable mirror image forms. ଗୋଟେ D ହେଲେ ଗୋଟେ L, ସେଇଟା ଲେଖୁନି. Already I have written down. Okay, guys who are watching in the YouTube, stay tuned. Don't go anywhere. We'll be going up to 5. We'll do a lot of things. Then, without spending any more time, we shall be discussing Fisher projection formula. I think we have written that yesterday, right?
Yes, sir.
I have already explained to you the Weiss formula. Actually, we will write down once again for the benefit of those who are watching today. These are called the Weiss formula. These solid lines which have a shorter portion at the center starting from the atom and goes on expanding, but all are bold faced. These are called wedges actually. So I have got a different name for this. These two bonds or groups, they are lying above the plane, and this normal line that lies on the plane, and this broken line, the group or the bond, both bond and group, they lie below the plane, supposing PQRS. And I told you, if you make a slight tilt backwards, then you get another similar Weiss formula where the two will go down. P and Q will be lying down. So these two are similar. In many books, many places, you will find the second one more than the first one. I have already shown you that if Q and S, they are lying above the plane, P here is lying on the plane, R is below the plane. But here, P, Q are both lying below the plane, and Q, S, I'm so sorry, PR. PR are both lying below the plane. P is also lying because we have tilted a little bit downwards. That doesn't make R come up above the plane. It will remain. It will be tilted little up, still remain below the plane. Q and S, they will be tilted little upwards, but still remain above the plane. So these two, we will call it two-wedge formula because there are two wedges. Wedge formula, but two-wedge formula. But this, which we were calling it funnily as flying wedge formula, I don't know who has given this name, I don't understand, but let us call it one wedge formula. Two groups or atoms, they will be lying on the plane, any two, either in this side or that side, anywhere, and one will be lying above the plane. So it is one wedge and one below the plane. So P, Q, R, S. So this is one wedge. So we can call this a one wedge formula, which funnily called flying wedge formula. And now, what is Fisher formula, which is more easy to handle? That is also a projection formula. It is the projection of the wedge formula on a vertical plane. Just write down, I'll explain to you. The vertical lines are actually the bonds or the groups lying below the plane. and the horizontal lines are the bonds and groups lying above the plane. Now see, before I show you the model, I take, it's better to take a two ways formula to demonstrate. To convert two ways formula, either that one or this one, to Fisher formula. I'm taking the second one. The first one is same. This is the central, say, carbon atom. This is one ways above the plane, the other ways below the plane. Supposing this is P, Q, R, S. Now, you imagine P, Q, P and R, they are lying below the plane. Just imagine they are lying below the plane. Thus, supposing this is the plane, P and R are lying below the plane and they are vertically. They are lying below the plane but vertical. And Q and S, they are lying above the plane and horizontal. We have kept in that way. Supposing you imagine a plane passing at the middle, this one, which I am telling, this one, middle one, that plane. And you take a projection, a reflection of all the bonds and atoms to remain on that plane. That is called a projection. So that will be looking like this. The one which are really lying above the plane, Q and S, will produce horizontal projection. That shadow, for example, projection means shadow. It will form a shadow horizontally. It is lying like this in a horizontal plane, but its shadow will be producing and that plane horizontal. So this is Q and R. Therefore, I wrote the horizontal lines are the actual bonds which are lying above the plane. And those which are lying below the plane, vertical plane, but projected downwards, below, then its shadow will form on the same plane vertically. So P and R, therefore I have written the vertical lines in the Fisher formula. This is Fisher formula. They are the bonds and the groups actually lying below the plane. So I'm showing you.
Sir,
Hmm.
sir, you have written R 2 times.
Oh, P, Q, R, S. Thank you. Thank you. Now see, we already told you that for a molecule, tetrahedral molecule, to be optically active, it has to have 4 different groups. At least 2 identical groups will have a plane of symmetry. Passing through the non-identical groups and carbon atom, that is a plane of symmetry, which will make the molecule a chiral. So if at least 2 identical groups are there, 2 hydrogen atoms, 2 chlorine atoms, 2 methyl groups attached to a carbon, then such a molecule cannot be chiral. It is symmetrical because there is a plane of symmetry. But if all the 4 groups are different, I have shown you here. Yesterday I showed you and now I'm showing you 4 different groups. This is achiral because it doesn't have any sigma, doesn't have any I. Because groups are different, so there is a center. If you draw lines, then there is nothing here. There is nothing here. So no I, no Aja, and no SN. Methane has a S4. This is not methane. All the groups are different. So it doesn't have a SN. But you don't expect that it should have a CN. In other molecules, I will show you a molecule having a CN is chiral. This doesn't have a CN. Every molecule has a C1 axis. So that C1 axis is called an identity element. In the group theory, for mathematical purpose, they take a dissymmetric molecule. Even dissymmetric molecule, if you rotate by 360 degree about a vertical axis, then it will be regenerating the same form. The C1 axis is not a real axis. It is called an identity element, E. So for mathematical operation, matrix operation, have you been taught matrices now in mathematics?
No, sir, it is in 12th.
Oh. So there are a lot of matrix operation there in group theory, which are very interesting. What I was saying, I forgot.
Sir, showing the chiral center.
Yeah. So this is a single chiral center, one chiral center connected to, I think we have written asymmetric carbon atom. We have defined it, right?
Yes, sir.
Yeah. Now, if we keep like this, the green is towards you, that is P, and the red is above, I mean towards me, above the vertical plane, which is Q, and S is also above the plane towards me, and R is below the plane towards you. So if you take a reflection, then the green and white, which were there in the vertical plane but projected downwards towards you, they will be giving shadows vertically on the horizontal plane. And the ones blue and red which were towards me, they were in a horizontal plane, no doubt, but they will give a projection, a shadow in that vertical plane through horizontal lines. You got it?
Yes, sir.
Yes.
Well, then we will talk about the absolute configuration now. You know, this is the same thing will happen for this one, because the reflection, if some bond, some group is lying on the plane, its mirror image will be also lying on the same plane. The projection, the shadow will be itself. Yes or no?
Yes, sir.
So both the two ways formula 1 and 2, they will be converted to Fisher formula easily. The one which you find, below the plane and on the plane, below the plane and on the plane, they will be projecting vertical lines, and those which are above the plane, they will be projecting the horizontal lines. But this one way formula, is little intriguing. Now, I would like you to give me, supposing I will say, I will draw the structure of lactic acid once again, which is a representative. The first optically active compound discovered by a biologist is lactic acid, is this one. You convert it to the Fisher formula. This is a two ways formula. Once you are given a two ways formula in any question or any book like this, you can easily convert it to the corresponding Fisher formula, which is a planar structure. Done? Can you annotate here, Miss Sami?
Yes, sir.
Annotate here. Guys who are watching in the YouTube, I find that many are watching as well as watching later. Yes, undoubtedly you will be gaining the expert level knowledge from my 45 years of teaching in university and then popularizing in school level. Yes, this OH and methyl, they were in the vertical plane. So they will give vertical projection. COH and H, they were in the horizontal plane, but they're projecting upwards, I mean above the plane. So they will be giving the horizontal projection. But just erase it. So this is two ways formula, and this is the Fisher formula. Is very easy to convert two ways formula to Fisher formula. But how to convert one ways formula to Fisher formula? I will give you the rules. Rule is, first draw the first place the group which is lying below the plane, which can be known by broken line, in any vertical position, up or down, any, because the vertical positions are really below the plane. You can select any one you like. First, you attack the one in the 1s formula, which is lying below the plane, represented by broken line. Then draw or place other three groups in the same sequence, either clockwise or anti-clockwise, whichever is suitable to you, in the other positions. I will give you an example, then you will be expert. Say, I will draw another, not always lactic acid, I will draw, supposing I will draw this CHO. This is, say, not always this time, I'll say chlorine. This is hydrogen. Or say ethyl, ET. Why always hydrogen? Let me write down Me, short notation of methyl. So here this is one ways formula. In one ways formula, you will find one broken line. So you first put a cross. Fisher formula is just a cross. One cross. Allah sabka sorry, Allah. Beta kaun?
Jesus.
Jesus is called the Father and the Son, the Holy Father. So, ago attack karo the one which is lying below the plane. Put it in any vertical position. Where? What do you want? Up or down?
Sir, up.
Then I will do the opposite. Wherever you want, put it. Because that two vertical lines are really lying below the plane. Then you just cross it. Because it will create some confusion, so you cross it. We have already placed it. Then start from any group you like. Supposing I will start from chlorine and go clockwise. Supposing you will start from methyl and go anti-clockwise. Okay. You follow a sequence. Start from anyone, chlorine. And here, from anywhere you can start. Supposing I will put chlorine here. I started from here. Then to its clockwise position, you will find methyl. So to its clockwise position, you will place methyl. Clockwise, I am following clockwise. So this is a clockwise position, methyl. And to the clockwise position of methyl is aldehyde. So this is already gone. So to the clockwise position, other three positions left are this, this and this. So to the clockwise position of methyl is aldehyde. So this is same as this. So we have correctly converted a one-ways formula to Fisher formula. You will see that you will encounter no error when you assign the absolute configuration. Then, can you do it? Understood, Miss Tripathi?
Yes, sir.
Miss Tripathi wants to give another example, I'm sure, because Kalo Tharo Kalo Ma Jane, not because I'm her grandfather, but in general, Kalo Tharo Kalo Ma Jane. So this time I will give you another one. I will ask you to. So can you tell me the name of this compound in one flash, in one go, without looking to and without numbering? Can you name this compound in IUPAC?
Sir, 2-chloro, 2-methyl, butan, 1-al.
1-al is not written. If you write 1-al, people will laugh at you. Although it is correct, but simply butanol, right?
Yes, sir.
Nicely. 1, this is 1, 2, then there are 80 means there are 2 carbon atoms, 3, 4. So that is the longest chain, butanol and 2-chloro, 2-methyl, butanol. Okay, we are not interested in the IUPAC name, but I will give you another example with say OH. This is methyl. This is bromine and this is hydrogen. And the name of this compound is 1-bromo-ethanol. Ethan 1-ol, obviously ethan cannot be 2-ol, so it will be 1-bromo-ethanol. So this is a chiral molecule because the asymmetric center, this is a chiral center connected to 4 different groups, OH, H, bromine and methyl. You can, no, use Sami, I want Sami to annotate here. Maybe you commit mistakes, doesn't matter. We are here to commit mistakes. Keep it in your mind that we are here to commit mistakes. Not necessarily ଆର୍ଥରକ ମୁଁ ତଳେ ଦେଇଥିଲି ବୋଲି ତମେ ତଳେ ଦବ ସେମିତି କିଛି ମାନେ ନାହିଁ ସେଟା କାଟି ଦିଅ h ଟାକୁ କାଟି ଦିଅ h ଟାର କାମ ବଢେଇ ଦେଲ so you just remove h from the first structure because you may create some it may create some confusion अरे h टा कोड होला h टा लिखि गला what happened to h the one which is lying below is h that has to be placed first in any of the 2 vertical positions, up or down. You selected down, doesn't matter. Then you started from OH and went anti-clockwise, doesn't matter. You are so very cool. So C started from OH, C first wrote OH, then to its anti-clockwise position is methyl. So the anti-clockwise position is methyl. And to its anti-clockwise position is bromine. So she has written bromine to its anti. Perfectly, these two are identical forms. That is a Weiss formula. This is a Fisher formula. You will find the configuration that we will generate R or S will be completely error-free. Correct. Hela, livai dio. Buji parlo to? You got it?
Yes, sir.
Those who have joined now and have not understood correctly how to convert one Weiss formula, what we funnily call flying Weiss formula, to Fisher formula. Just wait. We'll be doing a lot of examples. Now, the CIP rule to determine the absolute configuration of a chiral center. The 4 groups are assigned relative priority on the basis of the atomic number of the first atom. And in case of tally, of a tie, the subsequent atoms are considered from higher to lower atomic numbers. I will explain everything. The first point of difference makes a group to have higher priority. Greater the atomic number, greater is the priority. Greater the atomic number, greater is the priority. So let me read out the 4 groups are assigned relative priority 1, 2, 3, 4. And just write down 1, 2, 3, 4. On the basis of the atomic numbers of the first atom in the group or atom. Atom thile the atom, group thile first atom. And in case of a tie, the subsequent atoms are considered from higher to lower atomic numbers. The first point of difference makes the group to have higher priority. And greater the atomic number, greater is the priority. So let me tell you that methyl is having less priority than ethyl, less priority than propyl. Propyl has less priority than isopropyl and so on. Why? Because chiral center is here. The group is here. Chiral center is here. The group is here. So the first atom bonded to the chiral center is same. Here carbon, here carbon, here carbon. Then the subsequent atoms in methyl is hydrogen, but the subsequent atom is carbon. You don't look to the lower atomic number. Start looking from the higher atomic numbers to lower atomic numbers. The first point of difference, once you find a higher atomic number bonded, and here all are hydrogen, then ethyl is having higher priority than methyl. Then comparing ethyl with propyl, N-propyl, carbon-carbon tallies, and the 2 hydrogens. This carbon is bonded to 2 hydrogen and 1 carbon. This carbon is also bonded to 2 hydrogen and 1 carbon. Rather, we say 1 carbon and 2 hydrogen. And this carbon is bonded to 3 hydrogen, but this carbon is bonded to carbon and 2 hydrogen. So this is the point of difference which makes N-propyl having more priority than ethyl. But why isopropyl is having higher priority than propyl? Because the first carbon is same. And here this carbon is bonded to 1 carbon and 2 hydrogen, but this carbon is bonded to 2 carbon and 1 hydrogen. Obviously here 2 carbon and this carbon is bonded to only 1 carbon and 2 hydrogen. This carbon is bonded to 2 carbon and 1 hydrogen. Therefore, isopropyl is senior to N-propyl. In the same manner, we can say that ethyl is having less priority than vinyl, which has got less priority than ethynyl. Because, a double bond is to be considered as this carbon is bonded to 2 carbons, 1 carbon here, the other carbon here. And this carbon is bonded to 2 carbon, 1 carbon here and other carbon here. You just remove the double bond and put 1 carbon on this and 1 carbon on this and then tally. That is the way how you tally. Now the first atom bonded to the chiral center is same. And this carbon is bonded to carbon, 1 carbon and 2 hydrogen, but this carbon is bonded to 2 carbon and 1 hydrogen. Therefore, vinyl is senior to ethyl. Ethynyl is still senior because you consider this as bonded to 2 carbons. Triple bond is converted to single bond and thought as if each carbon is bonded to 3 carbons. One is here, the other 2 you have to add hypothetically. Then if you compare these two tallies, but this is bonded to, this is bonded to 2 carbon and 1 hydrogen, but this is bonded to 3 carbons, this, and this. So ethynyl is senior to vinyl. I hope you understand what I'm saying. Sami?
Yes, sir.
Yes, sir.
Now I have a question for you. Between isopropyl and vinyl, what sign I shall give? Which sign, less than or more than? Isopropyl and vinyl. You consider, as usual, remove the double bond, make it a single bond and put one more carbon here, one more carbon here. Then compare. Which is here? Tell me, then I will explain whether you are correct or.
Sir, isopropyl will be less.
What do you say?
Yes, sir, same. Sir, isopropyl will less.
Precisely, because this is the point of tie. I mean, we were considering this as a chiral center. So this becomes a tie. And this is bonded to 2 carbon and 1 hydrogen. This is also bonded to 2 carbon and 1 hydrogen. Then we go to the second. Here carbon is bonded to 3 hydrogen, but here the carbon is bonded to 1 carbon and 2 hydrogen. So the point of difference is here. Now, once again, this carbon is bonded to 2 carbon and 1 hydrogen. This carbon is also bonded to 2 carbon and 1 hydrogen. Then the next one. Next carbon is bonded to 3 hydrogen. Anyone, you can go any one direction. 3 hydrogen, but next carbon is bonded to carbon and 2 hydrogen. Therefore, the isopropyl group is junior to vinyl. And now, tell me another one. Hydroxymethyl and vinyl. Both are connected to a chiral center. These are not chiral center. This is not a chiral center. These are the groups. You have to assign priority.
Sir, hydroxyl group will get a higher priority.
What do you
Yes.
say, Miss Sami?
Yes, sir, same.
So what sign I'll give? Less than or greater than?
Sir, greater than, less than.
Precisely, because doesn't matter it has 1 carbon. This is bonded to 2 carbons. This is bonded to 2 hydrogens, no doubt. But एक oxygen भारी पड़ेगा, 2 कार्बन को 1 ऑक्सीजन भारी पड़ेगा. इसलिए मैंने कहा था from higher to lower. The first point of difference doesn't matter whether it is bonded to 2 carbon, but 1 ऑक्सीजन जहां रहेगा ये entire group को higher priority दे देगा. So this is senior. Even if there is a double bond, 1 oxygen will make hydroxymethyl senior. Similarly, if you say compare between say carboxylic acid and this is not the IUPAC rule. Forget about the IUPAC rule. So this is acetyl and this is aldehyde. These are the three groups I have kept in such a manner that either you have to put less than or greater than. What?
Sir, greater than.
Precisely. Why? Because this double bond O is to be treated as if this O is bonded to a carbon. This carbon is bonded to an oxygen. You remove the double bond and do that carbon is bonded to 2 oxygen. So carbon is bonded 1 oxygen here and another oxygen I put it. And this oxygen is bonded to 1 carbon here and another carbon here. So you then consider the same thing, you do 1 carbon, 1 oxygen and do the same thing, you will find these 2 are same, but in the next one, this is an oxygen, this is a carbon. So, but in this case, you will find the one is a hydrogen, this OC, this O, and this is H. So this is H, and this is C, and this is O. So the first point of difference, 80 has to G, 80 has to G, 80 has to G. So unlike IUPAC rule, the aldehyde is having a higher rank in the type C functional groups than ketone. But here, the acetyl group, which is a ketone, that has a higher priority in CIP rule than aldehyde. Carboxyl group has a higher priority. You understood?
Yes, sir.
If you have a a cis, supposing a group is like this, this entire is cis, this is connected to a chiral center, and the other one is a trans. So according to convention, cis has greater priority than trans. Just remember, this has been a accepted rule that cis is having greater priority than, and deuterium is greater priority than hydrogen. R has greater priority than S. Supposing on one side, we will talk about, just to write down R is greater than, similarly RR or SS is senior to RS or SR. We will be knowing all these things later. Just to write down, leave a bit of space, something we will be doing. And then the second rule says, view the molecule opposite to the least priority group. And start looking at the other three groups. Least priority group is 4. 4 is below you, and you are in front. You are viewing, start viewing the other three groups in the sequence. 1, then 2, then 3. If the eye rotates clockwise, then the configuration is R. R is the Latin word rectus, stands for right-handedness. So R, that configuration is called to be R configuration. And if I rotates anticlockwise, it is S. Sinister, it is left-handedness. Rotates anticlockwise or counterclockwise, it is S configuration. लिख लो. Over. Over.
Yes, sir.
Yes, sir.
In the Fisher formula, it is very easy to handle. I'll show you. Then group number 4 is kept on a vertical position, which is lying below the plane, and clockwise eye rotation from 1 to 2 to 3 makes it R. Anticlockwise makes it S. If group number 4, least priority group, is in a horizontal position, the vertical position रे नहीं, जबरदस्ती नहीं आसिबो. Then two switches, you know, I have already told you that if you make two switches or any even number of switches, the configuration remains the same. Then two switches are made to bring the group 4 to any vertical position. Or the students, they cheat. A cheating rule has been created, which is called golden rule. I used to call golden rule. Or opposite rules are applied. If the group number 4 is on the same side of the viewer, or in the Fisher formula, it is in a horizontal position. Kichi thorei parucho?
Yes, sir.
Actually, horizontal positions are lying above the plane. ମୁଁ ସବୁ ବୁଝଉଛି ଶୁଣ. And that, what is opposite rule? 1 to 2 to 3. ଯଦି clockwise rotation ହବ ତାହେଲେ S. 1 to 2 to 3 ଯଦି anti clockwise ହବ R. ଠିକ ଉଲ୍ଟାଟା. ପିଲାମାନେ କାହିଁକି ଏ ଧନ୍ଦା କରିବେ? ଯୋଉଟା ହାବୁଡରେ ପଡିଲା, whatever comes to the Fisher formula, accordingly they put, if it comes to a vertical position, normal rule, normal CIP rule. If it in a horizontal position, then opposite rule. That I will show you. Now see. Now see. Supposing hydrogen is white, green is OH, blue is methyl, and carboxyl is red. Obviously, it is not IUPAC. OS टा कोटा नहीं थिले, green ना blue. अरे कोटा कोई थिली. Which one is OH?
Sir, green.
Green. So प्रथम atom टा O and carboxyl होची red. प्रथम atom टा carbon. This is O, which is having greater priority, OH or COH?
Sir, OH.
Tell me, Miss Sami, OH or COH?
Sir, OH.
OH. It's not IUPAC nomenclature. So OH, number 1. Number 2, between methyl and carboxyl, which is senior. Undoubtedly, methyl has 3 hydrogen atoms after carbon. But here, the carboxyl, C double bond O means 2 oxygen and another oxygen is there. So carboxylic acid is senior to aldehyde, therefore. So number 1 is OH, number 2 is carboxyl, COH. The number 3 is methyl, CH3. I'm sorry. This white is hydrogen. We have taken. It is up to our wish. So methyl is junior to carboxyl. Senior most is OH, and hydrogen is the junior most. 4, group 4. Priority 4. Priority 1, green. Priority 2, red. Priority 3, blue. Priority 4, white. And you view the molecule opposite to the least priority group, that is group 4. You keep the group 4 behind you and you look to the front. Not on the same side, but on the opposite side. And then start rotating your eye from 1 to 2 to 3. 1 is here, then 2 is here, then 3. My eye is rotating, not your eye. My eye. I am the viewer, not you. You means empty କରିବାକୁ ପଡିବ. Same result ଏକା ହବ. My eye is rotating anti-clockwise. Therefore, this configuration is S. Anywhere in the world you take this molecule, you will say S. 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 The absolute configuration is S. Whether S is dextrorotatory or levorotatory, we do not know. That is to be verified in a dark room containing polarimeter. Or if you have a prior knowledge about which molecule, which configuration, absolute configuration has which optical rotation, then we can say. Otherwise, we can't. But we can dare say, after writing the Fisher formula or Weiss formula, we can dare say whether it is R or S. Now, in the Fisher formula, after we convert a Weiss formula to Fisher formula, by chance, supposing, then let me tell you the cheating formula, that cheating rule that the students use. The intelligent students like you, they don't bother whether they are viewing, supposing they are viewing like this. The least priority group is on the same side of the viewer and the other three groups are on the opposite side. Doesn't matter. We will make the rule opposite. Anti-clockwise is
S.
Anti-clockwise is R. Clockwise is
Yes, sir. Yes, sir.
Now here, since it was really S, now my eye will rotate clockwise. So look to 1, which is green, then 2, which is red, then 3, which is blue. My eye is rotating clockwise. So this is S. So I really am scared to tell both rules to an average student who will be confused. So I will always say to bring or take the model in such a manner that you are viewing opposite to the least priority group, or if you are handling with Fisher formula, I'm just handling with a Fisher formula. Now this is a Fisher formula and I'm putting deliberately COH here, methyl here, OH here, H here. Now if this is number 1, write down number 1, this is number 2, number 3, this is a carbon bearing groups, but the next subsequent atom is oxygen, this is hydrogen, so carboxyl is seen here too, and this is the least priority group 4. And this 4, fortunately, in this particular Fisher formula is lying below the plane. Vertical position means below the plane, then you are lucky. Normal CIP rule you will apply. This is in a vertical position, that means below the plane. Actually below the plane. That means normal CIP rule to be applied. So C1, then 2, then 3. How your eye is rotating?
Sir, clockwise.
So put a clockwise sign here. At the middle, you show a clockwise arrow mark and then write it is R. So this is R lactic acid. Fortunately, I'm sorry, unfortunately, or fortunately, unfortunately, this has been found to be L or minus. R lactic acid, when taken to the polarimeter, it is rotating the PPL to the left. We'll know more about this optical rotation, how to find specific rotation, optical purity, enantiomeric excess, that we'll be doing, but we don't have time. So this is R lactic acid. And supposing what I am saying, supposing I will give you another structure where this will be Me here, ET here, COCH3 here. This is entirely as a group. This is a chiral center. And hydrogen, I will not take hydrogen this time. This will be chlorine this time. Now, before assigning, you first make 1, 2, 3, 4. 1, 2 का 4, 4, 2 का 1. मेरे नाम है लखन. So, which one is number 1? Tell me.
Sir, chlorine.
So, write down number 1. Then number 2?
Sir, COCH3.
Acetyl, yes, because all these 3 are carbon bearing groups. but this is bonded to oxygen. First point of difference, oxygen. This is connected to carbon. This is connected to hydrogen only. So this is 2. And between ethene, ethyl and methyl, which is senior?
Sir, ethyl.
This is 3. And the least priority group in this molecule is methyl, or what we say methyl. Now, unfortunately, methyl is positioning in a horizontal position. That means above the plane. I am the viewer. I am above the plane, and the least priority group is also above the plane. Then you have 2 choices. If you want to apply the normal CIP rule, then by somehow, without changing the configuration, retaining the same configuration, you have to bring the least priority group to any vertical position. I told you that making 2 switches, any 2 switches, between any 2 groups you make 2 times successively, you are not going to change the configuration. I've already told you. So supposing one switch you make between these 2, so that methyl has come here. Then you can make one switch and the next switch between these 2, or between these 2, whatever you like. So this is same as making 2 switches. Make 2 switches. So I'm switching between. So that is another way of learning. If you want to make 2 switches, it is equivalent to making one group static, fixed, and the other 3 groups you making a sequential rotation, like merry-go-round, what we play, singing chair or whatever. This will go here, this will go here, this will go here. Keep one group fixed. Our intention is to take methyl to either up or down. I have decided to take it up. You can decide to make it down and keep ethyl fixed, but I am making chlorine fixed and made a sequential redistribution of all the 3 groups. That is equivalent to 2 switches. One of the guys in 1 year asked me, sir, you made 3 rotations, I mean 3 exchanges, but how 2 switches? Then I said, you bring this here first, one switch, Me here and Et here, COCH3 here. This is one switch. Now, one switch means you have inverted the configuration. If I would have given R, then you have made it S. If I would have given, I had given you S, you have made it R. So you will get a big 0. So to retain the configuration and identify the absolute configuration, you have to make 2 switches. So this chlorine is fixed. Then I will make interchange between these 2 again. So I will again interchange between these 2. Is it not a sequential shift? I will bring COCH3 here and Me, Et here. I have already made Et and Me. So that what I did, I kept chlorine fixed and made a clockwise. I had to make clockwise because I have to take, I cannot make it anti-clockwise because I have kept chlorine fixed. It cannot come to the chlorine position. So we have to make a clockwise sequential shift. Me asila Et jaga ko, Et asila a jaga ko, and iska position ye aa gaya. So Et is here and COCH3 is here and Me is here. This is equivalent to 2 switches. Then apply the normal CIP rule. Look to 1, look to 2, look to 3. Forget about 4. 4, forget. So 1 को देखो, 2 को देखो, then 3 को देखो. कैसे मूव करता है आपका आंख?
Clockwise.
So what configuration is this?
Sir, R.
R, because this is a normal CIP rule. You have brought with so much of difficulty, you have brought the least priority group to a vertical position without changing the configuration by making 2 switches, which is equivalent to keeping one vertical group fixed and making a sequential shift like a merry-go-round among the 3 other groups with an intention to bring the least priority group from a vertical position to from a horizontal position to a vertical position. Got it? So this is R. Can you name this compound in one flash? Can you name the IUPAC rule? We just got a different priority. Yes, what is the IUPAC name of this compound? In one go. This is a ketone.
Sir, 3-chloro, 3-methyl, pentan, 2-on.
Precisely. 3, 1. This is 1, 2. This is IUPAC numbering. Don't confuse. So let us do it mentally. 1, 2, 3. This is chiral center is 3. Then ET is 4, 5. Ethyl. So this is pentanone. So 3-chloro, 3-methyl, pentan, 2-on, pentan, 2-on. And the designation is R now. Now you have got a designation. Chaudhary Charan Singh. That Chaudhary, the designation is R. This particular configuration is R. I don't know whether it is plus or minus D or L. I can't say. I don't have that data with me. I had the data with lactic acid. I knew. So I told. You understood?
Yes, sir.
Or you could have cheated. You could have cheated. I'm writing down the same one. Me here. ET here. COCH3 here. And bromine, chlorine here. And this is number 1. This is number 2. This is number 3. Number 4. कोई बात नहीं. लीस्ट प्रायोरिटी ग्रुप अगर हॉरिजॉन्टल पोजीशन में पड़ता है, इसका मतलब ये हुआ, oh, if you are a non-Indian fellow watching, hardly there is a possibility. Even if Hindi is the 4th most widely talked language after English, then Spanish, of course, then something, then Hindi. Yeah. So everybody loves Hindi. Namaste. You go to Europe. They, once you see that they're Indian, they will themselves from their own mind. Namaste. They have learned Namaste, karma, yoga, so many terms they use frequently. Karma. This is our karmic karma that has brought to this misery. Okay. So 1 to 2 to 3. Now we'll be using the golden rule, cheating rule. Let us write down for our own sake, opposite rule or golden. Just write down for the sake of fun, just to distinguish between the normal CIP rule and the opposite CIP rule. Let us call it a golden rule. cheating rule. So golden rule we apply because it is in the horizontal position lying above where you are, then opposite. Clockwise is S, anti-clockwise is R. Look to 1, look to 2, look to 3, then put an anti-clockwise. This anti-clockwise golden rule is anti-clockwise what? What?
Sir, R.
R. So it might be confusing, but you make sure if you are intelligent like you both, you will not falter because you know which rule you are applying, which formula that you are given. You are given Fisher formula that, or you have converted ways or one ways formula to Fisher formula without thinking anything in advance. Doesn't matter if by chance the least priority groups comes to any of the two horizontal positions, left or right, then apply the cheating rule. I mean the opposite rule, and say it's anti-clockwise R, clockwise S. But if you are really feeling really confused, then do the thing. Bring the least priority group with the 2 switches or the way I have told, and then apply the normal rule. Okay. So before we close, I will give you 2 things. One, a structure in the one ways formula. You have to determine correctly whether the same lactic acid, no, something else I'll be giving, something else, chloro, and this is ET. This is Me. So tell me what is you first convert. You can do it. You can look from this chloro, but it is better to convert to Fisher formula. It is always for the beginners. This is your ME. First, you convert to Fisher formula as you have done. Then, either by chance, if you find the least priority group is falling in a vertical position, normal CIP rule. If horizontal, then cheating. I mean, golden rule. You can assign whether it is R or S. This is the last thing that we will discuss. Then abruptly we shall close. You know, is it easy for any person to have the patience to watch for 2 hours, more than 2 hours? It's almost impossible unless one has a commitment, a dedication, which is usually not possible. Very, very challenging. You are sitting with someone and that someone is keeping you engaged, asking you to annotate and asking you questions. You are answering, you are in an interactive mode, but nobody is in interaction mode like those who are watching on the YouTube. Unless he or she is committed and wants to learn, he will just watch for few seconds, 1 minute or less than 1 minute, then switch off.
Yes, sir.
Maybe look to SST, how old he is now looking. Is he looking the same young man or he has become old? That was the intention, just to look and then switch off. That's it. What was your conclusion, Miss Tripathi? Is it R? And the name will be 2-chloro, 2-methyl butanoic acid. But what? R or S? Two of you cannot be different. First, Sami. And the one who is watching in the YouTube and with pen and paper, can you tell me, write down in the chat box what conclusion you got, whether it is R or S?
Sir, R.
Yes, Mr. Sau?
Sir, I am getting S.
Yes. So here there is a difference. So let me convert it to first to the Wage formula. Here chlorine is lying below the plane. So I have chosen any vertical position chlorine here up. Then I have forgotten this chlorine. Then I have started anywhere I like. I started methyl here. And then to its clockwise I find carboxylic acid. And to its clockwise I find ethyl. So this and this they are same. Then now number 1, number 2, number 3, number 4. Oh my God, I am unfortunate. Doesn't matter. I am a cheat. I'm a cheater. Some people tell cheater. I think it's acceptable now. Cheater. But when we were studying English in our school, cheat is itself is a common noun. One cheats is a cheat. Now they're called cheater. So it is in the horizontal position. I will be using the golden rule. Straightway 1 to 2 to 3, my eye is moving clockwise, and clockwise means it is S. And supposing someone is not interested in cheating, so he has to bring methyl. This time I am bringing methyl to the bottom. Keep chlorine fixed, and bring methyl to the bottom position. Take in an anti-clockwise manner, you have to shift. Then ethyl to this position and COS to this position. Now the fourth priority group is now occupying in a vertical position. That means below the plane. 1, 2, 3. So 1 to 2 to 3, it is anti-clockwise. So normal CIP rule, then it is R. Sorry, full हो गला कोड. It is anti-clockwise is S. Anti-clockwise is normal rule says anti-clockwise is S. So my I rotation is anti-clockwise 1 to 2 to 3. Anti-clockwise it is S, normal rule. The least priority group is occupying in a vertical position, and here it is occupying in the horizontal position. The opposite rule 1 2 2 3 is clockwise, and hence it is S. Golden rule S, normal rule is also S. You got it, Miss Tripathi?
Yes, sir.
What mistake you committed? You do it once again. Don't worry. You might be thinking that let us do 2 to 3 more. Yes, tomorrow we will start with Y2 until and unless two of you, or maybe if the others who have not watched come with preparation, then all are unanimous in your answer. I will be giving umpteen number of examples, converting 2 ways to Fisher, 1 ways to Fisher, and sometimes I'll give you the Fisher only, and then I will also tell you another zigzag line structure to them to explain, to represent or to depict the configuration. There is another, nowadays this is more popular, the line structure, the zigzag structure, that also I will tell you. So with this we conclude, and with one home task that will help you. You just write down in your individual ID what will be your with name. Complete identity of a chiral molecule is known when both the absolute RS and the relative plus or minus are known. Otherwise, it is not 100% complete. Lactic acid, you write R lactic acid, okay. You understand? Everybody can draw the structure, the form. But you have to say whether it is D or L. It is L. So minus R minus lactic acid. Lactic acid, R is minus. So this I am changing to I'm giving a very typical compound: vinyl, ethinyl, ethyl, and OH. Obviously, OH is number 1, ethinyl is 2, vinyl is 3, and it would below the plane पड़ीगला भाग्य को, तो এটা तुमको इजी हो. अच्छा, मु आउटे दउची फिशर फॉर्मूला, where I'll be deliberately keeping the least priority group here, ET. This is propyl, this is vinyl, this is OH. So a theta, the identity dabo, without giving a plus or minus, you do not know. You know, I also don't know. You only R and S is one chiral center. Tomorrow we'll see multiple chiral centers after convincing ourselves that we don't commit any mistake. So those who are watching, you can watch the video, yesterday's videos and today's videos, and come prepared next time. And if you really benefit and you have not subscribed to my channel, consider subscribing to my channel. This is a habit of any YouTuber that I am doing. So don't take it seriously. Doesn't matter whether I get a large number of subscribers or less number, but my real job is to disseminate my experience as long as I am fit. That's it. Bye-bye. See you tomorrow at the same time, 3 o'clock. Hello.
Pranam sir.
Thank you, sir.
এটা করি কি মতে দেব প্রথমটা